Assalamu alaikum wa rahmatullahi wa barakatuh, grade 3. Hope you are enjoying your weekend. In this last session, inshallah, we are going to talk about forces. But before starting, let's say دعاء اللهم لا سهلة إلا ما جعلته سهلا فأنت تجعل الصعب إذا شئت سهلا يا رب العالمين. اللهم إني أسألك فهم النبيين وحفظ المرسلين وإلهام الملائكة المقربين. اللهم إني أسألك قلبا خاشعا ولسانا ذاكرا شاكرا إنك على كل شيء قدير. بسم الله. In this lesson we are going to know what are forces and how everything around us that's moving has a force and everything that we are moving has a force. In this session we made an activity. We demonstrate how force affects motion, how force can make motion, how force can make object move fast or move slow, how the force can affect the speed, the fast or slow the object moving. We are going to apply strong force and a weak force on a two-way car to see how it will move. Weak force and strong force to see how will it move. Is it going to move fast or slow? So we are going to use tow truck, masking tape, meter stick, stopwatch. We are going to mark the finish and the start line with the tape, like that. What do you think? Why are we going to use a stopwatch? Why? To measure how long it takes to mark the start and finish line, or to measure how long it takes the truck to cross the finish line after each push, or to make sure the team members spend the same amount of time pushing the truck. Excellent. It's to measure how long it takes the truck to cross the finish line after each push. After the weak push, the weak force, and after the strong force. Which one will take less time and which one will take more time? So will the force affect the speed of the moving car or no? Through measuring the time. Then we will put the toy car at the beginning and push it. One time with weak force and the other time with a strong one, and we will record the time. What is the question of this investigation? Of course, our question is going to be how the force affects the speed of motion. How the force affects the speed, or how will the truck move when I push it in different ways? With weak force and with a strong force. How will the truck move when I push it in different ways? Make a start and finish line 1 meter apart with the tape. Why do you think we'll need a stopwatch, as we said? To compare how fast the truck crossed the finish line after push of different strength. After push with different strengths is how strong the force is. Strength can be strong and can be weak. To measure the time and compare how fast the truck crosses the finish line after push of different strength. Then we will push with a very weak force and time how long it takes the truck to cross the finish line. And we will repeat with medium force and with a strong one. What evidence do you have that you applied weak force? It moves slowly. The truck did not cross the finish line. That is the evidence that is the proof that you are using a weak force. The car cannot move fast. And what is the evidence that you apply strong force? The car pass or finish the line or pass the end point. The truck crossed the finish line in both times. And here we should record the time the car take to pass the finish line when you give it weak force and when you give it strong and medium force. Then we talked about the different types of forces. the different types of forces after we finish this activity. We talked about the different types of forces. Here, this man is moving the swing. What should it do to move the swing? He move it away from him. So is it a push or a pull? To move an object away from you, this is a push. He'll push the swing to move it. If you have a small rock, how can you move it? You move it away from you, and this is a push. This is a force. The force can either be push or pull. Pull when you are moving the object close to you, and push when you are moving the object away from you. So push to move the object away from you, push away, pull toward, close to you, pull, away from you, push. So I'm going to show you images and you have to recognize if it's push or pull. So, is this push or pull? This man tried to get the rope but close to him. We said close is pull. Excellent. When you move an object close to you, this is pulling. And this man moving the market car or this cart away from him. So is this push or pull? Away is push. Excellent. And this boy trying to lift the loads. He's lifting something, moving something close to him. So is it push or pull? What do you think? Close to him is push or pull. So this boy moving the loads toward him, close to him. Is he pushing or pulling? When we move something close, it's pull. Excellent. And what about this man that hang this stroller or these carts toward him, then move it away, toward it away? Is it push or pull or both? It's gonna be push and pull. As he hang it, so he's moving it close to him, then he move it away, so push and pull. Or he pull it at first, hang it, move it close, which means pull it, and then away, push. In page 69, which is about the dog sled, the dogs that are pulling the sled. There is a video we must watch about these dog sleds. Let's watch it. Bismillah. It's about the dog sled and how it pulled the cart or pulled the sled.
Each dog pulls with a certain amount of force. When all the dogs act together, they pull the sled with all their forces combined. The more dogs there are, the easier the sled is for them to pull. The dogs can also pull more weight together than if each one were acting alone.
Exactly. So, the more the dogs, the easier the pulling force. The more the dogs pulling the sled, the easier the force. And as they move, and if only one dog tries to pull this sled, it cannot, because its force cannot afford that. So your dog sled is sliding along on the snow. The dogs are happy and eager to run. All the dogs together are strong enough to move the sled. You can signal your dog to go faster or slower. Does it take a strong force or weak force to move the dog sled? How do you turn the sled left or right? Does it take strong or weak one? Excellent. It will take a strong force of all of those dogs. So the answer will be a strong force. And here, I like to move it. In page 70, you have probably made a swing move by giving it a force. So here we can find the meaning of the word force, so circle force, and we can find out that force is push or pull. When you push or pull the swing, you add force that make the swing move. When you push or pull it, push, moving it away, or pull it, moving it close, so your swing will move. If you push or pull a moving swing, you can make it move or even stop. So here, what makes the swing start to move? What makes the swing start to move? Is it air, force, or rope? Excellent, it's the force. The force makes the swing move. Exactly the pushing force. When you push the swing, move it away from you, so it moves. So what makes the swing start to move or stop? It's the force. Here we're having different force and we have to label it either push or pull. Let's start with B. Is the man moving, how the man moving the kid? Is he pulling it or pushing it? Pulling it or pushing it? He is moving it away, so it's a push. Excellent. What about this boy grabbing the turtle, grabbing the cart with the turtle or the stroller with the turtle? He is moving it closer to him, so it's pull. Excellent. What about this boy throwing the ball? He throw the ball, moving it away, so it's a push. Excellent. And these women moving the baby stroller, she is pushing it as she's moving it away. So away is push, close is pull. This in page 71. Pull, push, push, push. Here is the dog sled that we was talking about. In A, if the dog push the people, the sled may move but not very long. And here, if the people pull the sled, it may move but not very fast as well. If the people try to pull it, they cannot move it because they don't have the same force as the dogs. The dogs have more force than them. But if the dog apply a force to the sled as a team, it will move far and fast because they have a great force, a strong force, those dogs. Write your ideas about the best way for dog sled team to move the sled. Explain whether they should push it or pull it. They should pull the sled as a team because to move it far and fast. So they should move it as a team. They should pull it as a team so they can move it fast and far. If you cannot catch the writing, you can pause the video and write down. Here, if there is no dogs or no people push or pull the sled, The sled will not move. No one is pulling it, no force, no movement. But if the dog pushes the people, the sled may move, but not very far. But here, if the people try to pull it, it will move, but not that much because they have small amount of force. What if the dogs together as a team, they can move it far and fast, as we answered the question. Here, engineers. You know the engineers are people that are trying to make our life easier. They're trying to improve everything around us to make it easy for us. So they look at these dog sled race, and they think about it. How can we improve this sled? They said that this car or this sled must be made of lightweight material, like maybe wood or something that will not sink in snow, something that's light, not heavy, light. So it will be easy for dogs to pull it, and it will also not sink in the snow. Here, they should also make a good diet, give the dogs a good good food as they are working hard, a diet full of proteins and carbohydrates to give them energy so they can work hard and pull the sleds. What else? Dog sled race often goes through wilderness areas. Wilderness area mean area in the wild, open area. You may get lost in it. So the engineer said we must connect this sled with GPS device to help the racers find the way to the finish line, so they will not get lost. They find the way easily as they have this GPS. They will not get lost in the wilderness. So why would the large sled made of a heavy material be poor for moving through the snow? Because it will be large and heavy, and it may sink in the snow and be harder for the dogs to pull. It may sink in the snow and be harder for the dogs to pull. Why would a large sled made of heavy material be poor choice for moving through the snow? Select all that apply, which means we are going to select more than one answer. Is it because a large and heavy sled would sink in the snow? Yes. A large and heavy sled would be harder for the dogs to pull? Yes. A large and heavy sled would melt the snow? No. So the answer is A and B. Large and heavy sled would sink in the snow. Large and heavy sled would be harder for the dogs to pull. In session 3, we were talking about a strong and weak force. And we took this pizza man as an example. Here he is doughing the pizza, patting it. There is nothing better than a homemade pizza. The pizza maker uses a force to roll out the dough. And then the pizza maker push the pizza crust into the air with a gentle force. He's using a gentle force here to push the pizza crusts. And then this time he uses a strong force, which crust will come out better. Which crust will come out better? The weak force with the gentle weak force, or with the strong one? Which one? The gentle or the strong one that will stick the pizza in the roof or in the top of the floor? Excellent. It's the gentle one. The gentle force will make the crust better. Here is another strong and weak force. Put an X in the circle of the pictures that show the girl using a strong force. In which picture the girl is using a strong force to throw the ball more accurately? B. Excellent. What would happen if you threw the basketball with too much force? Here she is using weak force, and here she is using a strong force. Which one is better? It's the strong force. Excellent. And what will happen if we use too much force? The ball would probably bounce back instead of going through the net. It will bounce back and not going to the net, and maybe it will fly away and not going to the net at all. Here, do the math, the funny part. Why do dogs pull a sled as a team? We're returning back to the dog sled. Why are they pulling it as a team? Here we have dogs. Pretend that you are a dog sled driver. You must carrying a big heavy boxes on your sled. You know that each dog can carry or can pull half the weight of one box. Each dog can pull half a box of the load. Fill in the table to show how many boxes can be pulled by 3, 4, and 4 dogs and more. Let's see. Here, one dog, we know that one dog can carry half box. So 2 dogs can carry 1 box. Excellent. And 3 halves, half and half and half, which is 1 and half. 1 and half a box. What about 4? Half and half and half. 4 halves equal 2. Excellent. What about 5? 5 dogs will carry 5 halves, 2.5. 2.5 boxes. What about 6 dogs? 6 halves, 3 boxes. How does changing the strength of the force, it changes the amount of weight that can be moved? The more the strength of the force, the more the weight that can be carried. If we apply more force, we can carry more load. Here, increasing the strength of the force. The strength is how strong or weak a force is. Increasing the strength of a force make it possible to move a heavier object. When the force is decreasing, it cannot move as much weight. It cannot carry as much weight. Here, let's see the dogs playing the tug of war game. And let's see who will win.
These dogs are playing a game similar to tug of war with a round plastic disc. In tug of war, 2 forces are pulling on the same object but in opposite directions. If the forces are balanced, the object will stay in one place. If the forces are not in balance, the object will move in the direction of the stronger force.
So, who is stronger here? The golden dog or the black one? Who has more force to pull the tug? Excellent, the golden one. If they both have the same force, no one can pull it. It will stay in its place, and we call this balanced force. But if one of them has more force, so the force is not balanced, it is unbalanced force, the tug will move in the direction of the strong force. So, which statement about the video are correct? Select all that apply. Both dogs are applying forces by pulling on the toy. Yes, they both applying forces by pulling the toy. Only the stronger dog is applying force by pulling on the toy. Only the stronger dog is applying forces by pulling on the toy. Not only the stronger, both of them are applying forces. The motion happen in the direction of the stronger force. Yeah, the motion of the tug happen in the or of the toy happen in the direction of the stronger force. The dog pulling with a stronger force might also pull the other dog toward it. Yes, the dog that's pulling with a strong force can also pull the dog, not only the toy, toward it. So we have 3 correct answers, A, C, and D. Well done, guys. In page 80, we can find this question and this game that we have done. Dogs are playing a game like tug of war. The strongest pull wins. The strongest one will pull the toy more and will get it, and it can also get the other dog to its direction. It can also pull the other dog to its direction. So, which statement about the photo is correct? Both dogs are applying force by pulling on the toy. Yes. Only the stronger dog is applying force by pulling on the toy. Not only the stronger, both of them are applying forces, but the stronger one will win. The motion happens in the direction of the stronger force. Yes. The one that has a strong force will get everything, will pull everything toward its direction. The dog pulling with a stronger force might also pull the other dog toward it. Yeah, so A, C, and D. Here are players changing the direction of the object by pulling it. Sorry, by pushing it, I'm sorry. So players use mullets to apply forces to the puck. The force of the mullet change the direction of the puck and send it into the other goal. Let's see, Bismillah. How will they change the direction of the motion by pushing it, and which push will it change the direction, the strong one or the weak one? Let's see, Bismillah. Push, weak push, no change in direction. It's a weak push. Let's see the strong push and what happened when he made the strong push. Okay, another weak push. Oh, push to push. They change the direction of the puck. The strong push make the puck change its direction. So the force can change the direction. Push back, change in direction. Push back, change in direction. No, push, not change in direction. But when he pushed back, he changed the direction, and when he pushed it with a strong force, it changed the direction of the puck. In page, but before going to the page, let's answer this. A push or pull by the mullet set the puck in motion. A push, excellent, because they are moving the puck away, so it's a push. It also changed the puck's direction, excellent. Here, what force set the puck in motion? Push or pull? Push, excellent. Is that in page 81? Remember, this is page 81. Is that force of push or a pull? Is it a force of push or a pull? We said it's a push force. What force make the puck change its direction? The strong force. Okay, a push from the mullet, both set the puck in motion and they change the puck's direction. Here is about the dog sled. We are going to choose to drive the dog sled up the step hill. They move slowly. Then you take them to the level path. They run quickly. When they run quickly, it takes strong or weak force to pull the sled up the hill. Strong, excellent. And how is the force to pull it over level ground to a lower ground, to a lower level? Weaker force. More, greater, or stronger, and this less or weaker. In session 4, we answered the lesson check. So please go and answer the lesson check. If you find any difficulty, don't hesitate to contact us. Thank you so much for listening to the video. If you need any help, contact us. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.